Okay, so we started working with the graphing calculator, scientific calculator last time with trig ratios, and we need to get more into that here. So I just want to first review the process about how we're going to find a missing angle, and then we'll get more involved with how to use the calculator to get a missing side. All right, so first off, this right triangle here, what I want to do is set up a ratio that involves angle A, and then use it to figure out what angle A was. So as we mentioned last time, if angle A is my target, then what I want to say is this 17, that's going to represent my adjacent side because it's next to that angle. So I'll put a little A there. And then the 22 represents my hypotenuse, so a little H goes there. Again, the reason I label those is so that I can now go to SOHCAHTOA and figure out which ratio to use. So clearly, if I have an A and an H, I am talking about cosine. All right, so if I write a cosine ratio, cosine of A would it be equal to the adjacent side 17 over the hypotenuse 22. Since my input is missing, my angle is missing, that angle can be found by doing an inverse cosine. So inverse cosine of 17 over 22. Go to my calculator, type that up, and I'm getting approximately 39 degrees. Please take a minute to do that, to type that. Make sure you can also get 39 degrees. Just want to make sure that that is something that everybody is confident with on your particular calculator. All right, as you go down the page here, if we have any two sides of any right triangle, then either of the acute angles can be found using those inverses. But if we have the acute angle given to us and any one side, we can then do just a quick equation and figure out what that missing side is. So just before we get into that, some real quick equation solving. If you have x over 6 equals 5, what we would want to do is multiply both sides by 6, since it's showing division, so the multiplication will cancel that. X equals 30. You can try the others, go through those, but I'm just going to quick go through them as well. 3 equals 18 over x. Now, if you have x on the bottom, what you need to do is think of this as 3 over 1, multiply 3 times x on the one diagonal, multiply 18 times 1 on the other, and we can solve it that way. If you want to, though, you can switch that x and that 3, and so this equation can be written as x equals 18 over 3. And the reason for that is if I put this over 1 now, my cross products are exactly the same. So if x is on the bottom, you're allowed to switch it with what's on the left, and that will give you even more directly the answer that you're looking for. All right, for part C, I'm dividing by a. So if I want to solve for x, I can multiply both sides by a, and x would equal b times a. And again, x is on the bottom here, so if I just switch these, then x would equal a over b. Okay, so keeping those things in mind, as we do trigonometry, we're going to be able to find these missing sides relatively easily. So this diagram says the acute angle is 36, and the acute angle is 36, and this MN segment is 28. We're trying to solve for MP, so I'm just going to put a little X in that spot. Okay, so because this missing side is the opposite side from 36, just going straight across, I'm going to put a little O there. 28 is adjacent to 36, so we'll put an A there. So opposite and adjacent, going back to SOHCAHTOA. Think for a second which one that is. So it's the TOA, which means I want to write a tangent equation. Now, it's tangent of angle N, right? So I can put that angle right in because I know it, as opposed to the last problem I had to leave it unknown. And so OA for TOA means put the opposite on top, that's X. Put the adjacent on the bottom, that's 28. And now I can solve this the same way I was solving the ones on the previous exercise. Just multiply both sides by 28. And so the exact answer for this is x equals 28 times tangent 36. And if I wanted to put that into a calculator, the calculator is going to tell me it's approximately 20.3. Oops, 20.3. Yeah, so if you just take a second to type that, make sure that coefficient's in front. Because if you type tangent 36 first, you then have to make sure you close the parentheses on the 36 before times 28, and that sometimes gets messed up. So write the coefficient first, then put tangent 36, and you should get 20.3. All right, solve for the length of Pn. So I've got some options here now. If I'm looking for Pn, I'm just going to put a different variable here since I've already had x. Now that y is clearly in the hypotenuse position. So the best bet for this is to reuse the side you knew. So we were given the 28. I would suggest that you reuse the 28 because even though I now know that this is 20.3 and Pythagorean theorem would work, that relies on you getting the first answer right. So you're probably right, but in case you're not, it's best to go back and use the one that you knew. So I'm looking at the A and the H to solve this one. So that's cosine, the ka part of SOHCAHTOA. Cosine of 36 is equal to 28 for the adjacent over the unknown hypotenuse. Remember what we just talked about. If the variable you're solving for is on the bottom, you're allowed to switch it. And so the y is going to equal 28 over cosine 36. And that is the exact answer. The calculator answer, if I were to put this in and round it, is coming out to about 34.6. Okay, so there's a difference between an exact answer and a calculator answer. The exact answer has the trig ratio still in it, and then the calculator answer is the rounded version of what the calculator tells you. Okay, so on to the next page here. Keys to solving for a missing side. First, we have to know one side and one acute angle, so we have to have those two pieces of information. We want to identify what those sides are in relation to the angle, and that's going to help us pick the proper trig ratio, and then we just solve the equation. All right, so take a second to try number 4 using exactly the same procedure as was in number 3. If you need to look back, go ahead. Okay, so what I'm looking at here is I'm solving for BC, so that's where my x goes. And so now the 18 is in the hypotenuse position, so that gets a capital H. The BC is in the adjacent position because it's touching the 24-degree angle. So that's an A and an H, which tells me cosine. So I go cosine 24. Adjacent is x. Hypotenuse is 18. And I have my equation set up. So to solve it, multiply both sides by 18. That's my exact answer. And so as an approximate answer, I get 16.4. Okay, so that's exercise 4. Exercise 5, an isosceles triangle has a base of 26 inches and base angles that measure 64. Measure the height of the isosceles triangle. Okay, so let's do this. Let's draw an isosceles triangle. Okay, and it's got a base of 26, and it's got base angles of 64. Okay, so we've got that. Now, if I were to figure out the height of this triangle, I think what I want to do is just draw that in. So we'll go straight down from the vertex. Put a little right angle there. In an isosceles triangle, that altitude is going to split this 26 equally, so I'll have a 13 and a 13. Okay, and so I want to find that height. All right, so I'll put a little h there for height. Okay, so if I just focus on one of these two right triangles, okay, that 64 is my reference angle. The h there, the little h, stands for the opposite side, and the 13 stands for the adjacent side. Again, that's just for the right triangle component of it. Okay, so from this right angle here, this is my hypotenuse, right? So that's my opposite, that's my adjacent. I'm going to write a tangent equation. So tangent of 64 from the TOA, from SOHCAHTOA, is equal to my unknown height over 13. So my height in exact form is 13 tangent 64. And then that is approximately to the nearest tenth going to be 26.7. All right, now find the length of the legs to the nearest tenth. Okay, so those legs in an isosceles triangle has a different meaning than it does in a right triangle, right? So the legs of an isosceles triangle are the two sides that come from the vertex. So let's put an X in one of those spots. Say that this is the one I'm solving for. Again, I go with the 13 that I knew, not the 26.7 that I just solved for. So now, coming from the 64, I already had this as adjacent. The X is clearly the hypotenuse. And so if I write my equation using A and H, that's cosine. So cosine 64 is equal to adjacent 13 over hypotenuse x. Okay, so switch the x in the cosine 64, cosine 64, and that's going to give me an approximate calculator answer of 29.7. All right, let's finish this up. In right triangle PQR, Q is the right angle, so I'm just going to draw that. I'm not so worried about drawing it to scale properly. I just need to make sure that the correct letter is at the right angle. I just missed it. That's all right. Just fix that. Okay, so if I have my right angle here, that has to be Q. This can be P, this can be R, or vice versa. It doesn't really matter as long as Q's in the proper spot. Okay, so R is 48. Let's put that in. PQ is 11. Put that in. And which of the following expressions correctly calculates the length of PR? So I'm just going to put an X in that spot. So if I'm trying to solve for PR, my 11 is my opposite side because I'm going across from the 48. The X is the hypotenuse, so that's O and H, which tells me I need to be using sine, right? So I go sine 48 equals 11 over X. Well, that's not any of these choices. However, number 1 is the closest of those 4. Now, if I just take that and I quick maneuver the X over to the other side, I'll have X equals 11 over sine 48. Because it's on the bottom, I'm allowed to switch those. Now, I have that correct choice. Okay, so as you're drawing your own diagrams, just try to make them accurate. Try to make sure that they're labeled correctly. And then still go through this process of the O, the A, and the H, because that's going to tell you which trig ratio to use, and you're never going to get it wrong.